This query has a lot of duplication. There are three very similar select statements combined with union all keywords. The problem is that all of these tables are accessed multiple times, which could slow down the query. Can we make this better? First, we need to understand what the query is doing. Let's start in this first part before the union all, at the innermost subquery. We're selecting some data from the order line and product tables, where the product category is 5 and the status is A. In the next query outside of that, we are selecting the order date, but using the format function which will display the date in this year and month format. We're using a count function as well. At the end of this subquery, we group by that same format function. So it looks like we're showing the count of orders for each year and month. In the query outside of that, the only thing we show is this round function, which takes the average function and the value count column from the subquery and a parameter of 2, which is the number of decimal places. So it's finding the average value from all of the counts for all the months and rounding it to 2 places. Or, said another way, we find the average number of orders per month. In the outer query, we select a text value of group A, and then this value we have calculated. So we could say that group A represents the average number of orders per month, where the category is 5 and the status is A. Next we have a union all, then a select. This select query is almost the same as the first one. The only difference is the conditions in the innermost subquery. It looks for records where the product category is 1 and the retail price is greater than 15. It also labels this as group B. The final select query finds a similar result, but for products in the category 3 and a name that contains pasta. This is called group C. Let's run this query. We can see the results here. We have 3 rows which show our group A, B and C labels. Each of them shows a number. This query is a little complex, or maybe it's very complex depending on how much experience you have and how much of that you understand. But what's the problem? The main problem is that there are 3 select queries and they are all selecting from the same tables. This means these tables are being queried 3 times, all for slightly different conditions. This could be a performance issue, especially if the tables contain a lot of data. Each time the table is queried, it needs to fetch all of the data and then do the filtering based on the conditions we specify. There's also a lot of duplication in the code itself. Once we've processed the innermost subquery, we perform the same aggregation, functions and formatting several times. This query only has 3 separate select statements. You might have a query that has 2 select statements, or 5, or even more. If you need to change the logic, you'll need to do it in many places, which is time-consuming and error-prone. So is there a better way to do it? Yes, I think there is. Ideally, we would only select from each table once. We would have all of the logic and formatting and functions written once. Hopefully, the performance will improve. If the performance is better, that's great. If it's the same, it's also good, as we haven't made it worse. If the performance is worse, you'll probably need to assess if it's worth making this change or not. Let's try to improve this query. The first thing we'll do is write a query to get all of the product details that we need for our logic. This means the order date, the category ID, product name, retail price, status and order ID. We want to select from the custom order, the order line and product tables. We'll join on the primary key and foreign keys like we did in the original query. We can also format the order date column to the year and month format because all of our future calculations will be done on the date in that format. Now we can add a where clause. We don't need all rows from these tables. We only want rows that meet at least one of the criteria mentioned in the original query. The Group A rule said that the product category is 5 and the status is A. Group B is where product category is 1 and the retail price is greater than 15. Finally, Group C is where the product category is 3 and the product name contains pasta. We can add this to our query in a single where clause. This where clause needs to filter rows that meet any of the 3 conditions. We do that using OR and brackets. Within each of these sets of brackets we can add our logic. Now this query should show the records that meet any of these conditions. We can run this query to check that it works and see what the results are. The results show some products and the data we have specified. This is good so far. We're filtering our records to show data that meets our criteria. But the final result in the original query had a count for each of the groups. How do we know which of the groups each of these records belongs to? We can use a case statement. I'll surround this query with another select query. This makes it easier to refer to the column called order month, which is the formatted order date, rather than having to refer to the full function. Let's add some case statements. We'll add a case statement that checks if the criteria for a row matches the Group A criteria. If it does, we'll show the order ID. If not, we'll show null. We'll give this column a name of order ID A. Why did I do this? It will show an order ID if it matches the Group A criteria. Our original query had a count of values that met each of the criteria, so by showing the order ID, we can use this in our count function. Showing null for rows that don't match means that they won't be included in the count. We can add a similar case statement for the Group B logic, showing the order ID or null, and with an alias of order ID B. Finally, we add another case statement for the Group C logic. I'll add a name for the subquery at the end, as I've referred to it in the case statement, and this is often required for some SQL vendors. Let's run our query. We can see the results here. We have records that represent individual orders. We aren't grouping anything yet. We can see the order month for an order, and in the three other columns, we see either a null value or a number that represents the order ID. Now we have worked out how to display the rows differently according to their criteria. Let's start grouping the rows by month. We add a select keyword, then select the order month column. We want to count the records in each group for each month. We can do this by writing a count function. We'll count the records that are in Group A by counting the order ID A column. However, this is an order ID column, which is joined to other tables, so there's a chance that this order ID may appear multiple times. The count function will count this as 2 records, but we only want each order counted once. So we can add a distinct inside the count function, so we count the distinct order IDs. We can do the same thing for the other 2 groups. Now, because we're using an aggregate function here with a non-aggregated value, the order month, we need to use a group by. So I'll add a group by to the end of the query to group by the order month. Let's run the query. We can see the results here. Each month is shown in a separate row, and there are 3 columns that show the count of order IDs in each month. We're making progress. You'll see in the query that the logic and calculations are in one place so far. The logic for each group is actually mentioned twice, in the case statement and in the where clause. You could simplify this by removing the where clause and selecting all data, because the case statement does the work of showing the numbers in each group. So that's something we could try to simplify it even more. Let's add the next calculation to our query, which was the round and average. We could do this in the same query, or we could do this in another outer query. It's up to you. I find having these nested queries makes it easier to see the steps, but you might find it unnecessary and confusing. We want to select the average count value for each month and round it to 2 places, like we had in the original query. We can do this using the same set of functions. Let's run the query. We can see the results here, which shows just 1 row and 3 values, 1 count for each of the groups. We've got our 3 count values, 1 for each of the groups we had in our original query. We could finish our query here as the data matches. This would only be possible if the client of this query, such as the report or the application, can be updated to look at the values in the column instead of values in separate rows. If this is not possible, we can translate these 3 columns into 3 separate rows to match the output of the original query. We can do this using a feature called unpivot. It's available in most SQL vendors, and I'll show you how it's done in SQL Server. We'll surround our query with brackets again. With the select clause, we select a column called data group and a column called average val. These are not defined anywhere yet, but that's okay. At the end of our query, we add the unpivot keyword and open and close brackets. Inside the brackets is where we specify these two columns, and SQL Server will do its magic to translate it to rows. We specify the average val column, which is the number we want to show. Then we say for, then the data group. We have an in clause, and inside brackets, we specify the column headings that we want to show as rows. We then give this unpivoted data an alias at the end. Let's run this query. We can see the results here. We have 3 rows, one for each group. We see the group name, and then the number called average val, which is the calculation we did. If you want to rename the column headings, such as average val and data group, you can update them in the unpivot section and in the select clause. If you want to rename these labels here that say average A, average B and average C, we can do that in the select clause. We'll add a case statement to the data group column. We add when clauses for each of the current column names, and then give it a new name such as group A. This should mean our column headings are updated. We can run the query here and see the results. The labels are now updated to show the same values as we saw in the original query. Here is the final query. It's a little shorter than the original, at 53 lines compared to 63. But the tables are only queried once, instead of 3 times like the original query. The logic and functions are also only mentioned in one place. So consider a process like this if you have a query with a lot of union or union all statements, and want to explore the idea of simplifying your query and improving its performance. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you like this video, consider subscribing to my channel. Thanks for watching.